Good morning, sir.
Ma'am, can you hear me?
Yes, sir. Your voice is audible.
Ma'am, okay, ma'am. Just, ma'am, we will wait another 2-3 minutes because some network issue there. His system is loading.
Okay, sir. Yeah, sir. We can wait for that. Good morning to all the participants, and we will start the session within few minutes. Thank you. Sir, can we start the session, sir?
Ma'am, okay, but very less participants, almost 6. We'll wait another 2-3 minutes because 11 o'clock only.
Sir, we will be hosting the program in the YouTube, sir. Participants will join in the YouTube link.
Oh, I can't see here the participants.
No, sir.
Okay. Ma'am, 11:04 now, 11:06 we will start. 11:06.
Okay, sir.
2 minutes we will start, ma'am.
Sir, and one more thing, the participant will post the questions in the YouTube, sir.
Okay, ma'am.
And I will guide you through the questions, sir.
Okay, ma'am. Okay, ma'am. No issue.
Okay.
No issue. Ma'am, that sharing options, everything you've given to me, no, ma'am?
So we will have an introduction about you, sir. After that, we'll give you the permission for sharing the screen, sir.
Okay, ma'am. Okay.
So can we start now? It's 11:06, sir.
Yes, ma'am. Yes, ma'am.
Okay. Dear participants and respected speaker, a very warm good morning to one and all. I, Varlin Betty Cruz, Assistant Professor, Department of ECE, delighted to welcome you all on behalf of Gates Institute of Technology for the third day Faculty Development Program on Advanced Technologies and Challenges in Electronics and Communication Engineering, organized by Department of ECE, Gates Institute of Technology, Gutti. Ladies and gentlemen, and now I request Ms. M. Prashanti Madam to introduce the Day 3 speaker.
Thank you, ma'am. I am Prashanti, Assistant Professor, Department of ECE, and I'm privileged to introduce the Day 3 speaker, Mr. Vasu Galithoti, Assistant Professor, Department of ECE, Presidency University and Research Scholar from NIT Trichy. He did his BTech in ECE from KSRN College of Engineering, Kadapa, Masters in DECS from Annamacharya Institute of Technology and Science, Rajampet. And Sir is now pursuing his PhD in the field of digital image processing and machine learning from NIT Trichy. His areas of interest are digital signal processing, antenna wave propagation, machine learning, electromagnetic wave, and transmission lines. He has a very rich experience in the field of teaching from various colleges on courses like artificial neural networks, signals and systems, microprocessor and applications, basics of electrical and electronics. Sir has published 12 international journals, 11 national and 6 international conferences. Sir is a lifetime member of Indian Society for Technical Education and Internet Society. Sir is an associate member of Universal Association of Computer and Electronics Engineers and also an editorial board member of International Journal of Emerging Engineering Research and Technology, International Journal of Electrical and Electronics Research, and International Journal of Electronics and Communication Technology. Sir, we are very pleased to have you as the Day 3 speaker. Now, I request Sir to address the gathering. Thank you.
Good morning, one and all. This is Thirumal Vasu, presently working as Assistant Professor in Presidency University, Bangalore. First of all, my sincere thanks to Gates Institute of Technology, because this is my first FDP conducting as a speaker, because I attended so many international conferences and workshops, everything, but this is my first experience as a speaker. My sincere thanks to Gates Institute of Technology. And today, my plan is to give what is the advancements that we can go with antenna designs and antenna and wave propagation in that field. If time permits, I will explain, I will discuss how a data will be analyzed by using machine learning techniques. And this is a practical session, how a data analyst will do their work in a industry, the same that we will do today. And one more important thing here, this will be useful to you people while you are teaching like antenna and wave propagation. You may use this antenna design. And if you want to go with the machine learning and data analysis type, these things, then you may use these techniques also. This is useful for teaching purpose as well, because since this is a faculty development program, so finally ultimate goal for a teacher will be teaching, other than research and all that is secondary. First goal is to teaching the students. So this will be useful to you people, like in a different way how we can approach this antenna simulation and all that I am planning to discuss today. And feel free while you are contacting me anyhow after this session. I will post my office mail id as well as personal mail id, so that you can communicate me any by any means, like during if you want to go with a research collaboration with me, or if you want to go get a further information related to what I'm supposed to discuss today. These things will get you through our interaction. With your permission, let me open my screen so that I can directly communicate to you. I'm requesting the organizer. Can you give me the permission, ma'am?
Yeah, sir. Yeah, sir. Sure. Sir, we have already given the permission, sir. You have to share the screen.
Ma'am, but it is showing me, 1 minute, ma'am. It is showing some error. 1 minute, ma'am. Let me check it once. Usually we are dealing with MS Teams. Actually, I'm new for this Zoom, MS Teams and Google Meet. Okay, let me check it, ma'am. 2 minutes.
Yes, sir. Take your time.
It is loading. Launch meeting. నేను లేదు మ్యామ్, నేను ఆన్లైన్లోనే నేను బై ఓపెనింగ్ MATLAB I will explain. Ma'am, can you hear me now in that team? Is my voice audible? Video also properly, no?
Yes.
Okay, ma'am.
So we can see you, sir, now, and we can hear your voice as well.
Yes, ma'am. Can you able to see my paint window?
Yeah, sir. We are visible to see now.
Ma'am, can you able to see my paint window?
Yeah, sir. We can see this window, sir, paint window. We can see that screen.
Sir, you can start, sir.
Hello. Video off చేయనా? Okay, ma'am. ఒక్క నిమిషం. ఓకే మ్యామ్. ఒకవేళ నా ఆడియో మీకు వినపడకపోతే నాకు కాల్ చేయండి మ్యామ్. ఓకే మ్యామ్. ఓకే మ్యామ్. ఆ పని చేయండి మ్యామ్. ఓకే. Ma'am, now check once. Can you able to see my paint window?
Yeah, sir. We can see it.
And can anyone confirm?
Yeah, sir. The screen is visible.
Is my voice audible?
Yeah, sir. Voice is audible.
It appears that he is not getting our confirmation. Our audio is not reaching him.
Sir, your screen and voice.
Yes, I hope my voice is audible.
Yes, sir. Yes,
Please,
sir.
anyone confirm once?
Yes, sir. It
So
is
that
audible. Your voice is
I
audible.
can
Sir.
start.
Yes, sir. You please start the session, sir. If there is any problem in the audio, we will let you know, sir. Thank you, sir.
Okay, now first, the main target of today's session, we need to analyze the antenna radiation pattern and the current distribution and the radiation field at azimuthal plane and elevation plane. And why we are doing is, first, let me consider here one example. This, let us assume this is antenna radiation pattern. So this antenna radiation pattern, this we'll call it as a major lobe. This one is called it as a major lobe. And this we'll call it as side lobes. These four are called as a side lobes, and this one called as a back lobe. So in generally, the main application here is radar application. In radar application, the major problem with the side lobes and back lobe. Suppose if the side lobe energy level, suppose if it is less than or equals to 20 decibels, there is no problem with the radiation. But if it is almost approximately equals to or equals to 30 decibels or greater than 30 decibels, greater than 30 decibels, that will be the major problem while you are targeting a object. So how to minimize this minor lobes, including side lobe and back lobe? How to minimize this? This is very important task and the fundamental challenge in communication, especially while we are concentrating on radar targeting. So if you want to go with this, how to minimize and how to analyze this type of radiation pattern by using antenna system, we have so many tools. Like one of the tool is say HFSS, then one more is IE3D, and our well-known, which we are more familiar with this is say MATLAB. So these HFSS and IE3D and MATLAB, all these three are paid version only, but in many institutions, we will have the MATLAB license. So in this session, I am targeting on this MATLAB, how to use and how to analyze this radiation pattern of a particular antenna, and how this major lobes and back lobes and minor lobes will be visualized, and how the current distribution will be happen within this antenna. Those things we are going to discuss today. Before that, let me discuss a few things related before my MATLAB will start. Let me discuss about the helical antenna. Today I am taking one example of helical antenna, general helical antenna. So with this helical antenna, we will analyze all radiation parameters. So the practical, a general example, I'm not copy from net and I'm not pasting here in a diagram. So let us consider here one helical antenna. Say, let us consider this is one helix structure, and this helix structure having some parameters. Suppose spacing between these two is very important. Suppose the spacing between these two, say S, and the overall length of this helical antenna from here to here, I can say axial length A, and the diameter and thickness of the helix will be D. So like this, some parameters will be monitored to identify the best design of the helical antenna. So in order to design this helical antenna, they predefined space and circumference chart will be there. From that space and the circumference chart, we need to be identify how much will be the axial length and how much will be the each loop length, and how much will be the spacing between these two, and what will be the thickness of this helix. All these things will be calculated by using this space circumference chart. So here, if I consider the length of each loop, suppose if I consider here one single loop length from here to here, if I consider one single loop, say L, and the total circumference, of the helix, say C, then spacing between these two is S. So few parameters like S, L, and C, circumference and length and spacing between each turn, if I consider, then the relation is, I can make it as one mathematical equation for this is, say, S, L, and this is C. And this will be the pitch angle alpha I can. So with this relation, I can decide how much will be my spacing between each turn, and what will be the each turn length, and what will be this circumference of the helix. So all those things I can calculate. And this helical shape, this helix will contain three different shapes by considering here axial length only, and each loop, and circumference and diameter. So these things I can able to communicate by using these three parameters, SLC parameters. So this is one basic introduction about the helical antenna, because I'm not going much into this this design and all. Directly I will discuss the design part of this helical antenna by using MATLAB. Okay, and here if you go further to this helical antenna, there is transmission mode and radiation mode, where I can use this helical antenna as a transmission line itself, and I can use this helix as a radiator also. So these things are some fundamentals related to helix. Now I will discuss how to design this helical antenna and how to analyze this helical antenna practically with respect to MATLAB. By using this MATLAB, how we will do that. Let me stop sharing my screen and let me open my MATLAB window. Some issue with opening this MATLAB, be patient. It is showing busy, please write. Still it is showing busy. Now, let me create one directory for today's workshop. Yes, I created. And the next step, we need to go here. There is a provision in MATLAB that we can go with MATLAB programming also .m files, or you can have some applications over here in the application tab. What I'm using here is R2019A. In R2020A, 22A, a few more features are added, but I'm using still 2019A. Here, there are some applications like machine learning and deep learning applications, maths and statistical applications, and control system and design analysis. And this makes the user comfortable, which they can directly apply their inputs and their parameters in a particular design, and they can. Suppose if you want to go with machine learning applications like a classification, regression, even if you want to go with neural network applications, you can use this many apps. And suppose if you want to go with the signal processing applications like antenna design and audio control devices and filter designs and wireless communication, even wireless sensor networks. Everything we can use by using signal processing and the communication toolbox. And these are the toolbox, these are the applications which are related to image processing application. For this today, for this session, I'm going to take here antenna designer. So this antenna designer, if you are comparing this already existed softwares like HFSS and IE3D, your MATLAB is almost, this is a user friendly. Suppose let me tell you an example. Suppose if I want to design a patch antenna. So if in order to design a patch antenna using HFSS software, I need to choose what will be my substrate and what will be the material and what will be the dielectric and what will be the dielectric constant value. Everything I need to choose from my end, so from user end. But the advantage of using this MATLAB application is, so all the parameters are inbuilt with this antenna design application. There simply you need to select which one that you want to prefer. You need not to be knowing about what will be the dielectric constant of a particular dielectric material, and how much will be the length and how much will be the diameter and what will be the dimension parameters. These things from user end, from trainer end, you need not to be worried, because all are predefined by using this. I can able to use by using this antenna design application. So let me click on this antenna design application. Depending upon your system speed, it will open. Still it is loading. Let this application will open. And I'm telling you one more time, the main enhancement or main future scope of in this antenna design, and what we are targeting here is this targeting with minimizing the minor lobes. So this minimization of lobes in a specific applications. 1 minute, let me share my entire screen. Let me share my entire screen so that you will get to know what are the changes that I am doing here. Now see here, this is antenna designer application by the MATLAB. Now I need to click here for new design. See here, click in left upper corner, you can see a new design plus symbol. There you can go with a new design, and you need to wait until these all the predefined antennas that are enabled. It will take some time depending upon your system speed. Still it is loading. And one more interest research area in this antenna design and antenna analysis is minimizing the backlobe energy. The total radiated power will be distributed among the all lobes, major lobe, back lobe, and side lobes together. So the total power will be the same, and if you can able to minimize the back lobe and side lobes power, so that the major lobe power will be increases. But the problem and the major challenge and future trend here is, many cases, I mean 99.9 cases, there is no possibility, or very less possibility to suppress the back lobe to enter into the antenna system, because major lobe and back lobe both are aligned together with 180 degrees out of phase. As soon as your major lobe entered into the antenna system, defaultly your back lobe also trying to enter. But the major target here is we can't able to suppress or suppress up to 0 level of your back lobe, but we can able to minimize the power associated with the side lobes together. What I'm trying to say is the total radiated power will be distributed with major lobe, back lobe, and side lobes. I can say major lobe and minor lobe. So now, if I minimizes the unwanted radiated power energy with side and back lobe, so that the major lobe power will be better and it will be good. So that was the task if you are dealing with the radiated power. Now you can able to see here, these are the antennas that I can directly working on by using this application. See here, starting from waveguide and horn antenna. So there are dipole, folded dipole antenna and folded dipole family. And here you can go with the helical antenna, even monofilar helical antenna, and loop antenna family, they're circular and rectangular loop. And one more important thing here, patch antenna family. So generally the patch antennas will be related to VHF and UHF category, and this microstrip patch antennas also I can. And one more thing, frequency independent antennas like high frequency range and high bandwidth log periodic antennas also can able to simulate by using this application. Now let me choose here from Helix family. I'm taking here helical antenna. So now I consider here a helical antenna. So this helical antenna defaultly after I selecting here helical antenna, this will be the helix alignment here. So in this helical antenna design, first I'm going to choose here. Suppose if you want to go with the frequency of operation, suppose let me take here 9.5 gigahertz helical antenna I want to design for my application. So I need to select here 9.5 gigahertz, and I can go up to terahertz also, but I'm choosing now gigahertz operation, and I need to accept this design. It will take some time to open a antenna designer window with my 9.5 gigahertz helical antenna. Let me, still it is loading. That's what I'm telling you, depending upon your system speed, it will take some time. Still it is loading. Now see here, almost done. This is 1 minute. This is helical antenna, and left side here you can see the antenna properties. So the geometry of the helical antenna and how you load this helical antenna and these things. Come to one by one here. As we discussed earlier, that radius of helix and the width of the helix and the number of turns and spacing between each turn and winding direction. That means your helical antenna having some handedness, right-handedness and left-handedness. I can say clockwise and counterclockwise direction. And here feed stub, how to feed this antenna, that feed stub height and the ground plane radius. This is the ground plane for my helical antenna, and the tilting of the helix total tilt axis. So all those parameters I can able to modify here. So defaultly, after selecting here 9.5 gigahertz, these are the default values that is already created. And there is a provision to change also. See here, if I want to change here from 3 turn to say 9 turn, 1 minute, 3 turn to say 9 turn. Let me show. See here, I changed this helical antenna number of turns. Earlier, defaultly it has shown like 3. Now total 9 turns. And even I can change the spacing between these turns also. So this depends on our requirement. And you can use here CW clockwise wounding and counterclockwise direction also, and even this tilt angle also you can able to change it here. See, this is the tilt angle of 45 degrees, and let me go with the 0 degrees angle only. And here you can go with how to load your helical antenna with the impedance and frequency and location of the feed also. So if you want to get the further information related to this helical antenna, how many parameters that I can consider and that I can include for my application, simply here uh, just you open help here and go to antenna toolbox. Click here antenna toolbox and go to here antenna catalog, and in this antenna catalog these are the different families of antenna that I can able to perform the analysis by using this MATLAB. And if I want to go with my helical antenna, what I'm presenting now, see here Helix antennas. So in this Helix antenna, again, I need to go here, Helix, what is my object here? So it will give you the lot of information that what I can do with the manipulations or managing the parameters. See here, just now what I explained here, radius, width, okay, number of turns, spacing. So everything I can able to get it from here with this help. And if you go here, the default radius what it is showing here 0.02, 0.022 the default value. So we can able to change this also. And even if you are very good in programming, directly you can go with the programming also without using this application. Directly you can go with programming, but most of the time better we will use the application only. Now come to the point. Here, see, this is my 9 turns helical antenna with 9.5 gigahertz frequency. Okay, and for this, if you want to go with the radiation pattern, there is a column here, 3D pattern on the top. So this 3D pattern will give the 3-dimensional radiation pattern of the helical antenna. So in this, most probably you people may know that the radiation pattern in the radiation pattern analysis will be happen using azimuthal plane and elevation plane. Let me 1 minute. It is opening. It is opening. It will take some time. It will take some time. It is adding pattern plot here. You can able to see the comment adding pattern plot over here. Still it is loading. Okay, generally the analysis of radiation pattern will be happen using azimuthal plane and elevation plane. If you take x, y, z as a 3-dimensional quantity, and xz plane will call it as a elevation plane, and the xy plane, ground plane or base plane, will call it as a azimuthal plane. And with this, I can able to analyze that radiation pattern using 2-dimensional also with respect to azimuthal plane and elevation plane. Let it be open. Still, it is showing adding pattern. We'll wait some more time. Still it is loading. That comment you can see here, adding pattern plot. After it finish, it will show finish pattern plot. Suppose these parameters, suppose if you want to analyze in HFSS and IE3D software, there you need to use all these parameters, but defaultly it will generate. Now see here, this is 1 minute. See here, this is 3 helical antenna. Suppose if I want to do antenna for one application. So in this application with 9.5 gigahertz and maximum decibel values of 8.7 and minimum value of minus 15.5 decibels if you want to generate. So this radiation pattern will showing like this. And here, if you observe this diagram, this radiation pattern, the side lobes, that the side lobes occupies more radiated power here, more radiated power when compared to this major lobe. Now what we are our intention, we need to reduce this side lobes and back lobe power so that the major lobe power should be more. That's what our intention. Now for my application, if I want to go with the 9 turns uh, counterclockwise radiation pattern, sorry, helical antenna. So this by showing this sideband, total power, almost major power will be distributed within the side lobes only. So what I need to do, I can go further here and I can change the number of turns to make my radiation pattern will be good. Let me go here. Now let me change here to 3 turns. Okay, now let me apply. Let me apply. Now see here, for my 3 turns, how my radiation pattern will be. See here, still it is pattern is updating. Just please make a note of this radiation pattern. The side lobes occupies more power, so side lobe energy, side lobe power distribution will be more when compared to this. Now see here, the same 9.5 gigahertz antenna, helical antenna, now with 3 turns. If I change it with here 3 turns, now see, so there is a this is the major lobe now. So number of minor lobes, like including side lobes, the number of minor lobes are reduced here if I go with this 3 turns helical antenna. But operating frequency will be that frequency of operation will be at 9.5 gigahertz only. Okay, so like this for your application, and if you want a narrow air radiation pattern, then you need to change remaining parameters also, radius, width, spacing, these things also you can change and you can get the suitable radiation pattern for your application. Suppose if I want to change here the tilt angle to 20 degrees. Now let's see what happened to my radiation pattern. Because this helical antenna generally we will use as a directional antenna, so this will be depends on the direction of radiation also. Now see, again it is changes to, tilted to 20 degrees. The output of radiation pattern should be like this. Now let me show here that azimuthal plane and elevation plane. See, this is x-axis and this is y and this is z related to x and z. This radiation pattern, if I want to see from x and y, x and z direction, that means if I see from towards y direction, from y direction if I see, then I can able to project. The projection of y direction will be placed on x and z direction. So that will be comes as a azimuthal plane. And if I want to see the radiation pattern from radiation pattern of x and y direction, that means base plane, I need to project from the top, that means z axis, that will be elevation plane. Now see here with the azimuthal plane, this will be my radiation pattern. And 1 minute, let it be open. Now see here, this is the radiation pattern and a 2-dimensional radiation pattern. Earlier this is a 3-dimensional radiation pattern. What I can able to see here with the azimuthal plane, azimuthal angle with the 360, that means 0 to 2 pi or minus 150 minus 182 plus 180, and elevation plane 0 to pi, that means 0 to 180 or minus 90 to 90. 3-dimensional plane. Same if you want to analyze in xy plane, that you can able to see here in the azimuthal plane. So this will be my azimuthal plane radiation. There you can able to see here the directivity at 9.5 gigahertz. Okay, by keeping here the radiation pattern, how much it will be from 0 degrees, how this radiation pattern will be changed. So that I can able to modify by using my antenna parameters. So this is like up to my requirement will be fulfilled, I can change this parameter with some constraint. And this is the plot of elevation plane. That means see here, if you see from y direction, from here, from this direction, so you will get this particular shape on the xy plane. Now see here the elevation plane radiation pattern. Now in this radiation pattern, still this will consider this portion will consider it as a back lobe, and this two will consider it as a side lobe, and this back lobe and side lobe together we'll call it as a minor lobe. So our task is to how to reduce this back lobe power and side lobe power to make my major lobe power will be maximum. That is the future challenge in the antenna radiation pattern design. And even in this design, you can able to go with the current distribution also. See here. It is taking some time to adding the plot. Now see, this is the current distribution. This is the current distribution. And this current distribution with respect to the ground plane. See here, this is the from 0 to 30 amps per meter. This current distribution they given. And with respect to the ground plane, you can see the most of the current here. And if you want to see the feed point, you can able to rotate, and you can able to see here the feed point. This is the feed point to my helical antenna. So like that, you can able to analyze any type of antenna which we can get it from this application. And in this application, even you can go with the impedance values. One minute, it is showing calculating the frequency points. Still it is loading. It's loading. Wait a minute, please. See, this is frequency versus impedance chart. So resistance and reactance both. So like that, these parameters, you can write a paper by using this analysis. Straight away, you can write a paper by using this analysis. You need to have one particular idea. That particular idea, in my point of view, my agenda is reducing the back lobe and side lobe power so that I can get the major radiation pattern. Okay, so for this applications, whatever the requirement that how much, whatever I require that I can get it from this MATLAB. And one more thing here, if you want to export this, you need to go here directly. You can able to export your design through your workspace or even for a .m file also. Suppose if you want to export this, I need to click on here. To export to workspace, and you can able to get this. 1 minute. See, you can able to get this in workspace. It has to become here. 1 minute, I think doing some process. 1 minute. Yes, it is doing some process. So after exporting this to workspace as a cell array, you will get all these antenna parameters, all these values that you can able to make it as in our paper also. 1 minute. See here, antenna designer, antenna object is saving now. You can able to see in the workspace. See here. Yes. This is my helical antenna design. What and all I did now. So those things, if you want to keep as a mathematical and quantitative analysis, so I can able to get it here from this workspace. And one more thing, the same patterns, everything that I can export as a .m file also. So if I export as a script, then defaultly it will come here in your editor window. Let me wait. Already existed programs are showing now still. This program not yet appearing. Let me wait for some time to get that .m file also. Still it is generating. That's what my intention. Depending upon your system speed, it will vary. I don't know. Still it is happening. Wait a minute, please. I will show that .m file also. Straight away you can work on this .m files. This is the old stuff what I completed. Let me close all this. What happened to this? Actually, it has to generate a .m file in your editor window. One minute. Actually, program is there, but it is struck somewhere. 1 minute, please. Oh, yes. You can able to see here the program which is generated for our design, what we completed now. So this is generated by 9.6 MATLAB antenna, 10th March 12, and the design helical antenna. So these things directly straight away you can take it as .m file, and you can. And if you want to go with the workspace values, suppose if you want to get these values on your paper, like presenting quantitative analysis, what will be that azimuthal plane and elevation plane, what are the tilt angles, and these quantitative values I can able to get it from what happened. 1 minute, please. It is still loading. So I will show this object, antenna design, helical antenna design object. Yes, see here left, right side. See all this antenna parameter values that you can get it from here in a workspace. Like that, you can able to get these quantitative values, and even there is a provision like you can able to extract these images from your design. You need to go here, export only image. Earlier entire program .m and the entire analysis we exported as a into the workspace as well as .m file. Now the single images, the radiation, three-dimensional radiation pattern and elevation plane, azimuthal plane, and the current distribution. So all those things we can export as a .jpg, .png images also. So for this, you need to go here and you need to click on export, so that you will export these images for your reference. Like if you want to make it as in one paper, if you want to keep that in one paper, your radiation pattern showing and all, so directly you can export these images also. That provision also there. Like that, you can go with any antenna type design, and you need to specify your parameters, and you need to analyze the radiation pattern, and you need to change the parameters until you need to get your required radiation pattern. Like that, you can able to proceed with the antenna designer and antenna pattern and how to vary with. So these parameters, antenna to antenna, it will change. Suppose if you are dealing with patch antenna, then the parameters may be what will be the substrate, what will be the length, and what will be the thickness of the dielectric material, and what will be the width of dielectric material. So design to design, that means antenna to antenna type, this parameter will vary. I will show this also, this image how it looks like after I export as a JPEG or PNG file, that you can able to see here. See here, I can export as .jpg file, or I can export as PDF also. Now, if I want to export as a PDF, now see, let me save. Now the same PDF what I saved here, I can able to see here in my current directory. Where is my current directory? 1 minute. The system is a little bit slow, it is responding. You can able to see your PDF, what you generated for this application. You can able to get it as a PDF also. One minute, please. It will come as a PDF. I will show that PDF. Okay, parallelly, we will go to the query session. If you have any queries related to this, you can ask. Kavita ma'am, can you communicate those queries?
Sir, we have a lag, sir, between this Zoom and the YouTube. As soon as they post the questions, I'll let you know, sir.
Kavita ma'am?
Sir, is my voice audible?
Sir? Hello, sir? Sir, can you hear me, sir?
Ma'am, I'm not, ma'am, your voice is not audible, Kavita ma'am. Is my voice audible, ma'am? Any queries that participants are posted? Ma'am, I can't hear you, Kavita ma'am. Okay, no questions as of now. Okay, can I proceed with the next application then? Please confirm once. Let me open. Ma'am, can I proceed? Can I proceed with the next thing? Data analysis. Yes, thank you. I will proceed. Let me share my PPT. Let me share my PPT, 1 minute. Give me a minute time so that I can open PPT. Please give me a minute time. Let me close this MATLAB and I will open my PPT. It is taking some time. 1 minute. What happened? Give me a minute time. Sorry for the delay. Give me a minute time. This is opening. Yes, I hope you can able to see my PPT. It is not responding. We will wait. So let me give one explanation related to this data analysis. Generally, for this example, I took one labeled and unlabeled data. So this is actually captured by a iPhone in from one library. That means how many students that are available. Can you confirm once? Is my PPT is visible? Please, can anyone?
No, sir. You
Okay,
have
let me
to
assume
share.
that you can. 1 minute. Yes.
So we can see your screen, sir. It's visible now.
What happened to this? Okay, let me assume that you can see my PPT. So this is one geographical structure of first floor of one library. And here you can able to see 1, 2, 3, 4, 5, 6, 7 are different icons. That means assume a location points. Assume a location points. And horizontally we are naming here, this data is named as A, B, C, D, E, F, G, H, I, J, K, L like this. And vertically 1, 2, 3, 4, 5, 6, 7, 8, 19 up to 18 they are located. I'm repeating one more time. This is one geographical structure of one library, and in this horizontally they mentioned as A, B, C, D, F, G, H like this, and vertically 1, 2, 3, 4. Suppose if you want to locate the IBCon value 12, if I want to locate IBCon value 12, then it will be R15. R15 will be the IBCon value 12. So what I'm trying to tell you in this application is they captured some data. So that data is related to how many people that are using the library in a different nodes. Suppose if this is a reference section, how many students will be there by 10 to 10:30 in the reference section, and how many students will be there in 10 after 10, how many there in issue section, how many people are utilizing digital library, like that we are using, they given some data. That data I will show it now. Now see here, one minute please, let me share this Excel sheet. I provide to you, even I will give the link so that you can able to download from the data source. There is one, so many are there, Kaggle, UCI, these are the data source references. You can see here, this is the data what they captured from this library. And here you can see here minus 200, minus 78, minus 78, minus 77 like this. And these are the location points, as just now I discussed. P01, P02, these are the location points, and this is the time, date and time that captured the data. And these are the IBCon positions 1, 2, 3, 4, 5, 6, 7 up to 13. And what is this minus 200 and minus 77, and what these values indicates? Let me take one example. Let me take this point as an example. Suppose see here, R01 at IBCon position 3004 minus 80. That means a lower value will be indicating as a closer to that particular position. Suppose minus 200 means for that time and for that location it will be very far. Please try to understand. Minus value indicate, less value indicate it is very closer to particular position. I can say position. I can use a layman words here to understand, to make it understand comfortably. So minus 75 will be closer than minus 80. Minus 74 will be closer than minus 200. That means if you take this example, at location R02, at this particular time, your IBCon 03, it will be very closer at this time when compared to IBCon 3005. One more time I'm repeating, the lesser number value will indicate very towards close to the particular node, and minus 200 indicate almost very far from that particular node. Like that, this data they analyzed and they given as, if you go here with the last column, it will be I think 1430 something. See here 1420, and here up to 15 data labels, 15 data. So this much big data is there. So how to analyze this data and how I can make it as comfortable to me to analyze, that I am going to explain now. For this, let me open my PPT one more time. Let me open my PPT. 1 minute, please. Where is this PPT? Here it is. Yes. Now see here. First, description of the data set. Just now what I explained, and how this principal component analysis, how to apply this to the first tested data, and how support vector mission will help us to classify this data, and results analysis and future scope. Okay, this future scope is very important because this already existed, and what we can do the extension of our research work related to your data analysis. Now see here, generally the principal component, I will give you a overview of this. I'm not intended to explain more on PCA, but I will use the PCA how to do this analysis. So description of the test data, what I discussed earlier. So total 13 IBACANs values they given, 120 by 30, 120 by 15 is the total data set, and the minus value will be represented very closer to IBACAN value. Then the minus 200 will be very far or out of range I can take. So like that, this data will be calculated with this geographical structure. Then how to do this principal component analysis? Generally, the principal component analysis that we can apply for dimensionality reduction. Let me take you an example. Suppose some X student has to analyze with the different characteristics. Suppose by assuming 20 characteristics, I can identify one student. Instead, with only 5 characteristics, I can analyze a particular student. That will be very good to me. What is my intention here is, your principal component analysis will be a dimensionality reduction technique. I can able to analyze the huge amount of data with multiple number of dimensions. I can reduce the dimension, I can do the analysis. So for this, your principal component analysis will be worked out. How this principal component analysis will be working here is, first you need to identify the autocorrelation matrix of your total data set. Now in this case, let me go with this example. You will get to know the brief overall idea. So the given data what we have is a 1420 by 13 size. That means 1420 into 13 is the total data set. From this data set, if I want to analyze, I need to consider all this 1420 by 13. For that purpose, what I am doing, I am reducing this dimension. Same, I am not changing the data, but I am changing the dimensions of the data. For that, the procedure is, first we need to identify the covariance matrix. Since this is 14 by 13, then covariance matrix what I can get is 13 by 13. So since you know these things related to covariance matrix, you will get 13 eigenvalues from this covariance matrix and 13 by 13 eigenvectors. The next step is, I need to sort it either ascending order or descending order, all the 13 eigenvalues. So the example what I completed here, the same data what I showed to you through MATLAB, these are the eigenvalues. See, this is eigenvalue 1. So see, let me 1 minute. Something, see here. This is eigenvalue 1, and this is eigenvalue 2, and this is eigenvalue 3, 4. See, no, 190.16, 198.72, 261 point. These things what I'm highlighting now. See here. This is one eigenvalue, and this is eigenvalue. Like that, 13 eigenvalues I have. From these 13 eigenvalues, I need to choose the higher
value of eigen number. That means, see here, from this 13 by 30, 13 eigenvalue, I consider only last 5 because these eigenvalues are very more. See here, 5021 to 3237. So 5 eigenvalues I can collect. And one more important thing here is there is a algorithm. There are some algorithms which adaptively can take the eigenvalues. There is also a research scope where you can take this eigenvalue, but here manually I took here 5. But if you are applying some technology, some method where you can choose the suitable eigenvectors, that will be the research scope to this application. I'm repeating one more time. So after sorting this all values, in this case 13 eigenvalues, among these 13, manually I look it into the maximum eigenvalues of 5. 5 I taking care of my application. But if you are writing an algorithm, or if your research will be like that, how to choose these eigenvalues from this data set. Suppose if my data set is 1420 by 2000, then I can get almost 1420 eigenvalues, or 1420 by 200, then 200 eigenvalues I can get. Among that, how many eigenvalues that I can consider for my application is a challenge, is a research scope and research challenge now. That is a challenge actually. So, but this application we took here as a 5. You can go with your adaptive also. So after calculation of this, after identifying this 5 eigenvalues, I need to multiply this data, this corresponding data with my given data. So total explanation I given here. 1 minute. Here, see, this is X is my given data and R is the covariance matrix. From R, I calculated the transformation matrix of eigenvalues what I consider with 5. So what I'm going to do here, this given data will be multiplied with my transformation matrix. Now this transformation matrix will give multiplication of this. So 1420 by 13 and 13 by 5 will give my PCA output. That means instead of analyzing 1420 by 13 data samples, now without reducing any data, I can analyze the same thing with 1420 by 5 samples only. So before going to start your analysis, the fundamental and foremost step, I can say this is a pre-processing for your data analysis that I can able to do with my principal component analysis. Then the second step is the fundamental and the foremost step is support vector mission. So in this support vector mission, I need to tell you about what is this hyperplane. So support vector mission can perform both classification as well as this what your PCA will do. Combination of PCA plus SVM also we can perform. So I will give a brief idea by taking 5 to 10 minutes regarding SVM, so that I will go with the data analysis. Even I completed some outputs also with my classifier. I will show it a little bit later. Now coming to this support vector mission. Generally, this is the fundamental and foremost step for classification. So in this, we need to consider the hyperplane concept. So if I want to explain this hyperplane concept, let me take 2-3 minutes deviate from here to explain what is hyperplane, so that I will come to SVM little soon. Let me share my paint window to explain very simple manner how. 1 minute. Let me share my paint window. Okay, I hope you can able to see my paint window. Let me assume that you can able to see this paint window. Now, what is the concept behind this hyperplane? I mean 2-3 minutes I will spend it here. Suppose if I want to represent a line with respect to my X and Y, if I want to represent with respect to X, Y, suppose this is my line, then how I can represent this will be some AX1 plus B, Y I'm taking here again X2 plus C equals to 0. So in this machine learning terminology, I can replace this A, B, C with suitable weights. Very simple manner I am explaining. This A, B, C is the constant values. I can represent it as a weights, so that it will be W1 X1 plus W2 X2 plus W0. I can say W0 equals to 0. Suppose if you want to represent a plane in a three-dimensional quantity, suppose if you want to represent a plane in a three-dimensional quantity like this, say suppose this is my X, and suppose say this is X1. Instead of X, Y, Z, I am taking here three dimensions, X1, X2 and X3. Okay, if I want to represent, this is my one plane. Okay, how I can represent this? Simple, AX1 plus BX2 plus CX3 plus D equals to 0. In machine learning terminology, I can assign some weights to my X1 and X2, X3 and that constant. Then I can write it as W1 X1 plus W2 X2 plus W3 X3 plus again W0 or omega naught equals to 0. If it is a fourth dimension, W1 X1, W2 X2, W3 X3, W4 X4 plus omega naught. If it is a n dimension, I can write that equation as Wi Xi, where it is ranging from 1 to n, and last this sample omega naught, I am writing here omega naught is equals to 0. And further, for simplicity purpose, if I write this equation as omega transpose X plus omega naught equals to 0, this is named it as n-dimensional plane. Generally, we'll call it as a hyperplane. So since my data will not be the same for all my applications, it may not be a two-dimensional, it may not be a three-dimensional, many times it will be an n-dimensional data. At that time, the analysis or classification has to done with hyperplane, not with a line or a plane or a fourth dimensional, multiple dimensional plane, so that I can represent this hyperplane as omega transpose X plus omega naught equals to B. And one more important thing here is, suppose this hyperplane, if it is passes through the origin, then I can say omega transpose X equals to 0 and omega naught, this one will become 0 here. So this is my hyperplane which is not passing through origin, and this is my hyperplane which is passing through origin. Now my SVM, let me open my scale here. See here, this is now SVM, support vector mission. This is meant for classification generally, and I am using here omega transpose X plus omega naught. I am considering here it is a B. Nothing will happen, equals to 0, and this is a bias value. And this one, with this equation, I can able to analyze my support vector mission. After calculating this two lines, which is supporting by one line, so I can get the standard representation of the equation. Suppose this I can this line I can represent it as omega transpose X plus B equals to 1. If I take this as a reference, see here omega transpose X plus B equals to 0, then above this is actually -1 equals to 0. Then this -1, if I take it right side, it will be omega transpose X plus B equals to 1. Then the below this line, so this will be omega transpose X plus B, actually +1 equals to 0. So that if I write it as RHS side -1. So now I need to identify the distance between these two lines. Let me do one thing. 1 minute. Let me share my paint window one more time so that I will give you a better idea here. See, I'm going to classify the data. Suppose this is one data set and this is one more data set. Say here, this is one data set. I marked with red color, and this is one more data set. if I want to classify this data, I need to maximize the distance between these two. I need to maximize the distance between these two so that I can say the exact classification will be happen. Suppose if the distance between these two will be minimized, what happen? You can see here, if distance between these two, suppose data 1 and data 2, if the distance is very low, then there is a merging of two data points over here. So this is data set 1 and data set 2. So what is my intention is, I need to separate these two with very long distance. That means I need to make the distance between these two is more, so that the classification will be happen properly. That means this has to move this side and this has to move this side, so that the classification will be happen properly. That's what here in this application, what we did is the same thing. I'm going to make the distance between these two lines is maximum. That means I need to identify the distance between these two with some constraint, and that distance, if I calculate mathematically, it will be 2 by norm omega. 2 by norm omega. And this 2 by norm omega will give the distance between these two. That means rho. Rho is the distance between these two. Suppose it is very simple. If I want to make the distance between these two is maximum, that means rho need to be maximum. Then rho need to be maximum. Then your weight vector, norm vector will be minimum. Very simple. 2 by norm omega. If total value 2 by norm omega will it will be getting maximum total value, it has to maximum, so that I can separate this data and this data I can classify properly. For that purpose, we can make it as this W value is a minimum. Generally, we can speak that this support vector admission is a minimization problem with some constraint, not a maximization problem. But we are maximizing this. We are maximizing this distance between these two lines, but indirectly we are minimizing this W vector. And even if you want to go further terminology in this, how to minimize this, they are using steepest descent algorithm to minimize the distance between these two. Steepest descent algorithm, minimization algorithm with some constraint. What are those some constraint? We need to pick the first point over here, and I need to separate these 2 points with the rho distance. Like that, your support vector mission. Now, the mathematical result analysis, because if I open in MATLAB, it is responding very slow. So that I already did the MATLAB operation, and with the same, like going to the application. And earlier we selected antenna designer application. Now you need to select classifier. This one. Let me show here, because if I run with this MATLAB, no, it is taking long time. Let me show here in MATLAB one time, so that I will directly go with the results. Now, see here, again in the same applications, earlier we did with antenna designer application. Now we need to go here, classification learner. So in this classification learner, you need not to be write what is the code for PCA, you need not to be write what is the code for SVM and all. So all MATLAB toolbox will take care, and you need to choose this classifier, so that you need to upload. First you need to export the data into the MATLAB, import the data into MATLAB environment. That means what I presented the data in the Excel form. So this data you need to import into MATLAB environment. Further, you need to apply PCA. First step is PCA. That means we need to reduce the dimensions before analyzing the data. Later, you need to apply your algorithm. That means support vector mission as algorithm, kernel support mission. Okay, you can go with any traditional algorithms, or you can write your own algorithm. And one of my best suggestion is, before going to deal with the updated algorithms, better you go with the first traditional one and analyze that algorithm, how it is working, and then you go with your own algorithm. So after did this all the things, finally the window will be looking like this. Now see here, this is the original data that you can able to see in the MATLAB. This is the MATLAB environment where I did. And in the right side, you can able to see the different data with the color labeling. See, now I can't able to classify here. This is a multi-dimensional data. Okay, so now what I'm going to do here is, if I want to analyze, first I need to apply PCA for this. So if I apply PCA, 1420 divided by 13 data will be reduces to 1420 by 5 data only. So dimensions will be reduced. After that, if I apply my SVM classifier that you can able to see here directly. You need not to write mathematical code under. In the left upper corner, you can able to see the SVM, PCA and KSVM and different algorithms and the kernel algorithms. Everything you can able to see it by simply clicking on that. You can able to get all the plots. And the second one, the same data with suppose if I want to go with IBCon 2, 3, this will be my data analysis, and you can go for 3, 5, this will be analysis. Okay, and if I am using the same classifier with the Gaussian kernel, the resultant will be like this. And finally, what I can able to say here, the future trend and future scope for this is, suppose if you are using a SVM classifier for 5-dimensional output, that is not possible to show in the MATLAB because 1420 by 5. So 5 dimensions I can't able to see here. I can't able to show here in this plot, so that only 2 dimensions that I can. Among 5 at a time, I can see only 2 dimensions. And very important thing, if you want to increase the accuracy levels of your algorithm, better you can go for Gaussian kernel applications. So Gaussian kernel applications, suppose if you are using this Gaussian kernel, there are so many kernels which are available. You can go with a better one, and the better option will be going with your own algorithm, which will be do the classification properly. Now the trend is multi-dimensional analysis with the kernel applications will be the hot topic in this research area. So like that, you can able to analyze the data with less effort. I can say less effort, because if you want to go with the traditional programming methods and all, you need to again you need to write the mathematical expressions behind that. You need to analyze the data. But in MATLAB environment, need not to write all the codes which already existed algorithms, PCA, LDA, principal component analysis, ICA, independent component analysis, LDA, linear discriminant analysis, all those already existed that directly you can able to access. Further information, if you want to get here, simply even in the help, statistical and machine learning toolbox will be there. From that, you can able to get the required information for this. Now, if you want to run and show this is not responding, no problem. All the procedure I will mail it to you further. I will take one more data set and I will. And the same thing, suppose one more addition to this, suppose if you are dealing with final year projects in BTech, so directly they can go with, I will show one website where you can get a different data sets. Let me give 1 minute time. 1 minute, please. This will be very useful website. One minute, please. Still it is loading. Let me share the entire screen so that you will. In this website, UCI machine learning repository, you can get even Kaggle also there. So many are there, but what I feel this is comfortable. Even they make it as different data types here also. They mentioned here, and you can see here view all data sets. Okay, so many data sets with applications also they specified. Suppose if you want to go with classification, directly you can click here. So the suitable data for testing your algorithm. So you can get it here. If you want to go with the regression as your application, then the suitable data even they separated here. Okay, like that from this website, this is free only. You can able to get all the data sets, and even luckily they given the description also for this. Each and every data, if you click on suppose annealing, if you are using multivariant, in this they given you the description, data description also they given. How it is collected, what are the reference papers for this, and what are this attributes information, everything, all data set information they given here. Like this is from my point of view, this will be very good website to go to test your own algorithms for data sets. Generally in machine learning applications, collecting the data is very important. Luckily this website will give good information, I think sufficient information. So like that your classification also perform. And one more thing, you can able to give this data set. So suppose if you are if you want to give to your students, you may give suppose 3W data set. Directly you give this link to your students, ask them to analyze by their own algorithms, and the same data you can give it to different students and analyze with their own algorithms and compare both. Suppose 3 students, 3 different data sets, I mean same data set with 3 different students and 3 different algorithms. Then which one having the good result, that you can go with one paper. So analyzing the data analysis. Like that also you can utilize this. Even MATLAB also very good tool to go with the machine learning and deep learning applications also. And it should have a good requirements, good system specifications. So that is regarding data classification and all. This information I think useful to you people. Any queries? Related to even that antenna design. Actually my areas of interest related to machine learning, image processing and antennas. So if time permits, and next time we will see with the image processing applications. Any queries please? Kavita ma'am, can you communicate their queries so that I will try to answer it?
Sir, is my voice audible to you?
And one more thing, I will share it to coordinator Dr. Kavita ma'am, my personal mail ID as well as my official mail ID. Feel free to contact me. Even I am also a research scholar. I am interested to work with multiple domains. If anyone interested in machine learning and image processing, ma'am, your voice is not audible, ma'am. You are asking, is my voice audible? No, it is not audible, ma'am.
Sir, now is it audible, sir? Hello, sir.
Now I can hear you.
Sir, I think that there is a lot of delay, sir.
Ma'am, are you asking something? Okay, ma'am, if not possible, then you can type the questions, ma'am. I will try to. So one query, other than support vector mission, is there any substitute? So nowadays, convolutional neural networks, even advanced to that recurrent neural networks, you can use. Suppose if you are going with convolutional neural networks, it will be better substitute for SVM, I think, from my end, because that depends on our applications also sometimes. Suppose your data is the amount of data that you want to analyze is more. Suppose if you are dealing with directly images, I can prefer CNN. Suppose multiple number of thousand numbers of input samples that you want to analyze as a images and all, then we can go with CNN, convolutional neural networks. But even if you are performing convolutional neural network or PCA, whatever it is, first the pre-processing step will be PCA. Principal component analysis will help you to reduce the dimensions without damaging your data. So I can say the substitute, I can't say substitute, but better alternate. And one more thing, that depends on our data also. So convolutional neural networks, I can say substitute for your SVM. Whatever SVM can perform, that better you can perform with convolutional neural networks. Thank you, ma'am. And one more time, my heartful thanks to Kavita ma'am, because she communicated me in a very proper way. And even ma'am, sorry if I troubled you anytime by my messages and all my queries and all. Really so sorry. Even this is my first FDP in my career. I'm very, very, very thankful to Gates Institute of Technology. And I'm very much thankful to Gates Institute of Technology. I will do my better in future also. Thank you, ma'am. Thank you, Kavita ma'am. I hope in time we closed this session. Can we leave Kavita ma'am now?
A very good afternoon to one and all. It gives me an immense pleasure
Okay, ma'am. Okay, ma'am.
to deliver the
Sure,
vote
sure.
of thanks
Proceed, ma'am.
for this today's session. Thank you, sir. Thanks for giving your valuable insights.
But I can't hear that. Okay, that is live streaming. Okay.
Thank you, sir. Thanks for giving your valuable insights on the research field of antennas, on minimizing the side lobes with the practical operation using MATLAB and the data analysis using IBCon and machine learning. And we will use UCI machine learning, and we will let our students also use this website for analyzing the algorithm for different data sets. We will try to put the above explanation for the research study. Thank you, sir. And I would like to thank all the participants for contributing your time and presence in today's.
Can I leave, ma'am, now? Can I leave from the session?
And as
from this session, can I leave?
Meeting for the.
Okay, thank you, ma'am. I will call you.
At 11 a.m. to 1 p.m. Thank you. Thank you all.